Overall, in my lab, we're trying to get better at 3D printing robots. We're here on the campus of CU Boulder in the Engineering Center. In my lab, the focus is really on multi-material 3D printing. We're trying to bring together all the pieces that need to go into robots, and so that means things that are flexible, things that are stiff, things that can sense, things that can actuate. And so that comes down to being able to deposit different materials.
We're working with a lot of researchers at Stratasys. These researchers are doing very exciting research in the areas of robotics, soft robotics, embedding parts, making working components directly out of a printer. That we've recognized this and we need to take this to the next level with them.
The central challenge that we face is how do you bring different materials together in order to create some complex structure, some object that has functionality when it comes out of the printer. The current forefront is in multi-material 3D printing.
There's a lot of areas that we're going to open up, from advanced parameter editing. We're going to allow them to print air. We're going to allow them to print our cleansing liquid to increase the ability to have very small feature details, whether that's in microfluidics or soft robotics. This is being added on top of our existing voxel print, where we let these researchers write the script to process the files. They're creating their own digital materials.
What's really powerful for us about additive manufacturing is the ability to put material A next to material B, next to material C in a very close proximity and very precisely. We have a Stratasys J750, so that gives us the capacity to print with 6 different materials. I think so far we've been successful using additive manufacturing to make flexible structures that have multiple materials, to make completely printed robots that use a scheme of hydraulic actuation. When you can print with liquid itself, it's possible to purge tiny little tortuous channels and even blind channels. And that's an essential component of this particular robot. And so by printing the solid material and the liquid material at the same time, we can create these robots that can be actuated as soon as they come out of the printer, and we use the fluid as part of the actuation strategy.
They want to sometimes change the height of a droplet or change how much of the droplet is trimmed off. We're going to allow that so they can continue to further their research. All of these capabilities will be tied to this research package software. You know, to me, it's an exciting time at Stratasys. We're giving the access that we've never done. It's really empowering to the customer.